Hello, everyone, and welcome to this event. Today, we will be talking about big data. Big data. I'm super excited for this session, and I'm also grateful that you've taken the time out to join us this afternoon to sort of look into what exactly is big data. Yeah, how do we generate big data? How do we deal or handle big data? And also towards the end, there will be conversations about how to become a data analytics professional. Without further ado, I will hand you over to our speaker for today. His name is Ikenna. Ikenna is an expert data science consultant and is part of the Waymaker Digital network of consultants that help to serve multiple clients across different sectors in the UK. So I hope you have fun, enjoy, and I will see you again at the end of the event. Iken, over to you now. Thank you.
Okay. So thank you very much for having me once again today. It's always a pleasure coming on to talk about big data and machine learning and the likes. So these are topics that I'm very passionate about, and I really enjoy working on solving big data, machine learning, data science problems. So so today's discussion is basically just going through, not necessarily diving deep into this topic because it's very big, like the name suggests. So we'll just go, sort of break it down to the layman, sort of to understand what big data is, what the use cases are, where you can apply um, big data, and some of the challenges, and at the end we will just have a quick demo. So basically, what we'll be going through today, just these few points that I've put together. Just talk about what big data is, the four V's of data, use cases, ecosystem, and then at the end we'll just have a quick demo. So basically, people normally ask, what exactly is big data? How do you know when the data is classified as big? The fundamental idea behind big data is to do with the fact that we humans are increasingly generating data daily. For everything we do in our modern day lives. We're leaving digital footprints behind. We're creating massive amounts of data that is increasingly becoming challenging to store, to process, to gain insight from. So just to put some definition to what big data is, it's actually any data that's classified as extremely big, large, fast, complex, but structured and unstructured, cannot be stored and managed or processed using traditional management components like relational databases. It could also be classified or defined as a field of study that aims to efficiently analyze this ever-increasing large amount of data. The concept of big data has been around for quite a while. From the early days of the relational databases or the data centers. But what makes it more interesting is with the advent of social media, Facebook, Twitter, and the likes, with cloud computing and all of these. So the amount of data we generate, has gone from the traditional structured data to unstructured data, like I show in this picture, where you have structured data like the tabular data, the Excel sheets. But these days we're generating more PDFs, videos, tweets, likes, comments, streaming videos, video calls, Teams, and all the likes. All of these streaming, Spotify, iTunes, and all of these are generating data, massive amounts of data daily. So it therefore begs the question: how do we process this data? What sort of insight can we gain from this data? So having the data is not um, it's not really what matters, but what you do with the data. So that basically sort of gives us an overview of what big data is. So this picture sort of shows us, you know, amplifies how big um, the amount of data we generate daily. Without going, you know, too into details about this picture, we can clearly see the amount of um, data from the different social media platforms that we generate every day, every minute of the day. And if you look at the picture clearly, you wouldn't see the likes of TikTok and maybe even Snapchat. So it just gives us gives us an idea of how much data is being generated daily. And this trend will continue into the future. So we don't expect this to go, to go downwards. It's ever going upwards, with new technologies, with automated driving, electric vehicles, all of these are leaving footprints, creating more data. How do we process this? This therefore creates a lot of opportunities for people who are willing to go into the field of big data, because with this ever increasing data, the challenge will always be there. How to process them, how to gain insights from this data to add value to the businesses. So we talking about big data. You can't talk about big data without talking about the V, four V's of big data. What do these four V's stand for? The four V's basically is about the volume, the scale of the data, velocity, how fast this data is being generated by the day, how much data is being generated, the variety, the different forms for which this data come in, like tweets, the videos, from the different sectors, the veracity, which talks about how much trust do we have in this data? How much uncertainty in data? How messy data is? Do you really trust it? Is it accurate enough? And all of this. So it sort of gives us how the different perspective to big data. If you look at the volume, and you see most companies in the US have at least 100 terabyte data stores. That's just the US alone. 6 billion people have cell phones around the world, and this is increasing by the day. So it sort of gives us an angle perspective of how much big data really is. And you can't talk about, as much as all of this makes sense, but I think the most important thing about big data is, if the data isn't adding value to your business, then of what use is gathering the data and storing the data? So the most important thing is what you do with the data, not necessarily the data itself. The data is very important because you have a lot of insights of hidden knowledge within the data. So what you harness, what you do with it, is what really matters. So this sort of gives us an overview of the four V's of big data. Now, talking about the use cases, I'm just gonna think about the use cases. Hope you can still see my screen. So there are different sectors where you apply big data. So if we're talking about manufacturing, the use, how you apply big data to manufacturing, you're looking about preventive maintenance of machines. Big data can help predict equipment failure, operational efficiency, talking about the area where big data can help you, impact on the profitability, how much efficient you can be, your processes can be in the long run. We're talking about things like production optimization. How do you optimize your production, your production line? How do you predict, helps you predict when there could be failure on the line, are you stacking too much, um, you know, um, what do you call it, raw materials on how best to stack your raw materials, how best to optimize your production line. So big data can help you in that regard. With regards to retail, you can get a value from customer behavior, customer experience, pricing, and optimization. So all of this can help you drive, become more competitive in in your business. So the amount of data you generate from all of these processes, can help you understand the customers when things are about to fail. With regards to the healthcare industry, big data helps with research, cancer research, with COVID. We all knew what happened with COVID. They needed to have a lot of data to be able to test and understand the patterns, how these diseases transmit between different people. So all of this data comes, big data comes into play. Patients' experience and outcome. How do you, using patient experience, how do you use that information to better, to provide better patient experiences, better services to your patients? With regards to claims fraud, big data can help you detect fraud. Basically mostly used in the financial services where you can detect anomalies and outliers and understand when some claims or any transaction is fraudulent. Oil and gas also, you could use big data to optimize your processes, help with oil discovery and exploration equipment, maintenance, predictive equipment maintenance, like we saw in the manufacturing sector. Also in telecommunications, big data can help with optimizing your network capacity, also helping with telecommunication customer churn, how quickly are your customers leaving or turning over, how are you converting are your customers happy at the leaving, what sort of product can you offer to them, what sort of services can you offer to help them. So all of this you can do with big data, based on customer buy patterns. With regards to new product offerings, you can also use customer behaviors, what customers are saying, sentiment analysis, to sort of understand how, what sort of products customers are likely to go for, and what sort of regions, what sort of campaigns do you want to drive in certain regions to help become more profitable. So big data helps in all of these sectors. Financial services, it plays a very big part. So we can see that big data is not just limited to one sector or one field. It's something that that affects our daily lives, in all sectors. Even as we speak, we're generating data, we're loading stuff to the cloud, so there's so many things, there's so many ways with which we generate data, and what we make out of this data is what matters most. So with regards to the ecosystem, like I said in the beginning, this presentation isn't necessarily about going diving into the different technology stack, defining what happens end to end in details, but it just sort of gives us an overview and appreciation of what big data is. So if we're looking at end to end use case of what happens and the sort of technology that is used within the ecosystem. So a typical just be say a business has an idea to improve their process, and they want to understand how do we go about improving our process. What sort of data do we need to better understand the services we're offering or what customers are saying. So you have a challenge of sourcing for the right data, preparing the data in the right format, streaming the data into the relevant data warehouse or database, data lake, wherever you end users would process this, the business users would process your data from. So you can see there are so many technology stack that are used um, from the word go, where you store the data, where the source of the data, sort of technology you use, Apache, Spark Streaming, Kafka, Amazon, Kinesis, you use to sort of, ingest this data into your warehouse. It could be batch processing, it could be through streaming, live feeds. And then you have data engineers who build data pipelines to ingest the relevant data from the sources into your data storage. And you could have different data storages, and which are segmented and stored in data lakes, data warehouses, or databases with search and query capabilities. And so what I use in this space mostly is we use Airflow, Snowflakes, Click Replicate, Fivetran, DBT. So these are all data transformation and orchestration tools that help you get data from the source to the final destination. So so having gotten the data to the storage, you want to do some transformation, you want to do some sort of cleaning, to where the final end users, like the data scientists, data analysts, will apply analytics techniques, machine learning algorithms to gather hidden insights from data, and then visualize this data to business users, to management, to the key decision makers to sort of make decisions. So this sort of gives us an overview of the technology stack that it's quite a lot. So this just gives us, like, how do I put this? I'm just laying everything in one picture to sort of give us an appreciation of what happens in the space. So like I said, I started a demo where we just look at this very last end of the process, where we've made a decision on what data to use, we've ingested it, we've cleaned it, we've stored it into the data warehouse, and then we want to visualize it. So we'll be using Snowflakes and Power BI to sort of show just a quick, simple demo of what sort of happens in the real life. So, so like I said, with the advent of social media, big data, companies are beginning to the companies are struggling to handle, manage this amount of data that's being generated. So, so you need a way to easily process your data. You need a cheaper way to store your data and access your data. So this gave rise to cloud computing, which is basically the practice of using network of remote servers hosted in the internet to store, manage, and process the data, rather than having a local server on-prem, where you have to take care of, manage hardware, electricity, train people, manage the resources yourself. So cloud computing takes all of those away. It's, it saves you it's a lot of money in the long run. It's secure. It's all of the security, or most of the security, is handled by the cloud service provider. You've got flexibility of being able to scale and spin up servers, as at when needed. So all of this sort of gives you the benefits of using cloud computing. And as much as there are several cloud computing service providers, we've got three top service providers, which are Google Cloud, Amazon, web services, and Azure. So IBMs and the like, Salesforce and Alibaba. But these are the three top cloud computing giants that that you can sort of use to manage your big data services. As much as big data sounds good, anything that has two sides to almost everything. So you've got the good side, the benefits of big data. You also have the challenges that come with big data. So discovery, data quality, storage, security, analytics. Lack of talent. People. So as the data increases, it becomes increasingly difficult to find patterns in data and derive insights from the data. You need to do a lot of processing, a lot of cleaning to get this value out of your data. Data quality is also an issue with data governance, the uncertainty of data, conformity to facts, how you trust your data, even if this data actually provide you what you need to make your decisions. Storage management, data management with regards to storage, prevention from destructive forces, earthquakes and the likes, unauthorized access. And also these are modern day challenges that we face with big data. Knowing what data is fit for purpose, before you even begin your analytics to derive insights. And I think the biggest challenges or one of the biggest challenges for businesses these days are having the right people, the right talent to work with this increasing amount of data. Knowing the technology stack, the domain knowledge, and with this lack of talent, I believe brings opens up a lot of opportunities for people who want to go into the field, because most companies are willing to bring you in and upskill you, and there are lots of trainings out there, there are lots of opportunities, videos, materials, resources that people can lay their hands on to sort of upskill and get into the space. So yeah, so these are some of the challenges that big data processing, are faced with today. But like I said, it also creates a lot of opportunities for people to come in and solve some of these problems. Yeah, so like I said, we're going to have a quick demo, and we will be predominantly looking at data snowflakes, which is a data warehouse provided as software as a service, where you don't necessarily need to install anything. You just create an account, link so if you've got on-premise data where you're trying to, or most companies are migrating from on-premise to the cloud. So this sort of helps you connect to your on-premise data and migrate to your preferred data migration, or if you've got data from multiple sources and you want to consolidate them, and have a single form of truth where you can, process your data and create gain insights. So Snowflake sort of helps you with that, and the architecture sort of allows you to to store large amount of data and also perform compute, because storage and compute are sort of they sort of scale independently. So it's unlike the traditional database where you just have storage. This sort of it's sort of a game changer where you have storage and compute in one location. So it sort of helps you manage the data without necessarily installing, configuring, setting up large investment costs and all of those. So we'll be doing a quick demo with Snowflakes and Power BI, which is basically a Microsoft tool that sort of helps you to visualize and interact with your data. So you can connect to multiple data sources, Excel spreadsheets, cloud-based, or even within your data within your on-premise data storage. So it's a very good tool. There are other tools like Tableau. It does about the same as Power BI, but we'll just have a quick demo to show you what happens. So basically, so this is Snowflakes. This is what the interface looks like. So you've got you can create databases and data warehouse from the worksheet. So basically, this sort of shows you the databases that are already created. And you can share data within Snowflakes. You can connect to external data sources, and sort of gives you the data warehouses, which are the compute, and you can sort of manage or set the size and the number of clusters that spin up and spin down. And you can also set up auto suspend if it's idle for a while, for a number of minutes, seconds, or however you set it. It shuts down or just sort of suspends the warehouse so you don't burn credits. You've also got auto resume, which basically so it's suspended now. If I go into the worksheet and run any query, it automatically resumes that particular compute warehouse and begins to query. So basically, what I'm going to do is connect Power BI to Snowflakes, and I think it might be better if I share. Right. So just a quick. If I want to sign in, connect my data source to if I want to connect my data source to Power BI, what I do is just basically go to get data, go to more, and then select. Why is it slow today? And then search for Snowflakes. And then connect. I think I'm already signed in, so it wouldn't necessarily ask me for my login details. And then you need to get the URL for your Snowflake. Connect that with our HTTP. And then you select what compute power you want. So I'll just go for and then it's connect. And for this, we'll be using if it would connect. Okay. Yes. So I minimize this. So this shows me the databases that I have in my Snowflakes instance. So for the 1, 2, 3, 4, 5, 6, 7 databases, which are already linked to my Power BI, and we'll be using just this little script just to show you what you can do on Snowflakes and also Power BI. So we'll be using the compute the warehouse. We'll be using Snowflake sample data and database and schema. So if you can see here, we've got different data warehouse selected, different database selected, and different schema. You can either come here and change all of this, or you could just run this query and it'll automatically change. And for the database, we'll be using that schema, which we can see here. And we'll be using the customer table. We can just visualize the customer table, or rather just display what the customer table looks like. And also the orders table. That's what it looks like. Right, so within Power BI, select Snowflake sample data database, and then select the TPCH schema, seed tables, select customer table and others table. And you can do basic transformations here if you want to, but we wouldn't go into any of those, we just put the data straight away. Now you could either import a copy of data straight from Snowflake into Power BI, or you could use direct query, whereby you're querying the data directly on Snowflake. So I prefer using direct query, so you're working with the live data on Snowflake rather than working with a copy, because if you're presenting any if you have any visualizations that you're presenting to people, the data might have changed by the time the people are viewing the visualization. So we just work directly with Snowflake. So it seems it's connected. Slot A. Right, so that's our customer table and the others table, and we'll try and build a relationship between these two tables by just drawing the customer key to customer key here. And we can see it's okay. Let's see, we've got a one-to-many relationship. So if we want to display, so first and foremost, we can just sort of check the number of rows in the others table by running this query, basically just counting the number of rows. Because we've got about 1,500,000. If you want to see the top top 10 rows of the other table, you just select all from others divided by 10 and give the top 10 rows. If you want to take the average of the total prices per customer, you just select the customer name, total prices, take the average of the total prices to join the customer in the others table by the customer key, group by the customer name, order by the customer name. You run that, okay. So this sort of gives us total average of the average of the total prices per customer. If you want to see the average of total prices per market segment, like we did before, you join the customer and orders table on customer key, select the market segment, take average of the total prices, grouped by customers by market segments and order by market segment. If you run that, you see. So we ordered by markets. So if we order by so we see that make this descending. So this sort of tells you that the automotive industry tends to have higher spend compared to these other segments for this particular data, and the building segment had the least spend. So it's just basically drawing insight. So if you want to see rather than the average, you want to do the sum, take the sum, and you want to order by the sum of the total price. So the sum of the total price, we say there are more spend in the building sector than in the automotive, or if you take the average, you get more spend on in the automotive segment. So this is sort of analysis that you can do within Snowflake. So if we want to do a similar thing on Power BI on the same data set, you see that we've got customer data, customer table here, and the others table. If we wanted to just look at the table and see prices per customer, so you could customer name, check total prices. Why is it slow today? Okay. Right, so you can see we can either average. We can order this if it will let me. Yeah, so this sort of shows you the customer 74576 had the list total price of list spend, average list spend, compared to the rest of the customers. If you want to see the same for the segments, so we've got the market segment by total price. And if you want to see the visualize this market segment by total price. Yeah, so what we got, the pie chart we're showing here is similar to what we get from Snowflakes. So it just sort of gives you an idea of what you can do with Power BI, how you can connect to your data, build visualizations, build dashboards that you can share with your users. Without necessarily going too much in depth, so I just thought I put up this little demo to sort of show you how you can connect Power BI to Snowflake. You can also connect Databricks, Airflow, if you're doing transformations or data migrations and all of it. So you can connect all of this to data processing tools to Snowflakes and ingest data, perform data transformations using tools like DBT and Databricks. So yeah, so I hope this sort of gives us a little insight into what you can do with big data. And so yeah, go back to the other screen. So yeah, so thank you. So we've just shown you what you can do with big data, what you can, how you can link Power BI to Snowflakes and sort of perform some visualizations and yeah. So there are lots of opportunities, lots of areas, lots of career paths that one can take. In the data space, you can either go into data engineering where you build data pipelines to get the data into the data warehouses where the business analyst, data analyst, and machine learning data scientist can use to create really nice fancy models and visualizations that sort of add value and help drive the business to profitability. So yeah, so I think that brings us to the end of the presentation. So yeah, thank you for listening, and I hope I didn't bore you with my slides and the visualizations. Like I said, this basically wasn't a masterclass. It's just giving us a taste of what big data is, and sort of technology and challenges, use cases that that we see that big data can be applied to. So thank you very much, and I hope we have another session where we can talk and learn from each other. Thank you.
Thank you for that wonderful presentation. Iken, really appreciate it. And thank you for touching on some really salient points. I hope everyone has found it really useful, and the demo was super good as well. So thank you for that. I just want to quickly touch on our new offering that we are providing now to people who are interested in accelerating their careers in technology. If you want to accelerate your career in technology, this is not about certifications. This is not just about training. This is about momentum. And the website is www.momentumby.waymakerdigital.com. All together, one word. If you go to that website, you will see a lot of information. But really, the disciplines that we are covering at the moment are data analytics, agile business analysis, product management, and user research. So if you're interested, all you need to do is to complete an expression of interest in any of the disciplines. That expression of interest will allow us to get in touch with you, arrange an onboarding call to understand whether there's a fit in what you exactly want to achieve and what it is that we provide. If there is no fit, then there's no need to progress any further. If there's a fit, then we can also actually look at how best we can support you. You're going to have access to one-to-one mentoring, a forum for direct contact with your network of other consultants. You're going to have work shadowing, work reference, CV branding, LinkedIn optimization, and a host of other things to accelerate and give you that quick turnaround in your career aspirations, specifically focused on digital technology. Okay. The other thing that is worth mentioning is Waymaker Digital. We have our outcome-based offerings. So if you're a small business in the private sector and the public sector, what we focus on is to help you to achieve your outcomes. We have services that cover agile software development, delivery of web development services, business analysis, research, cloud computing, whether that's AWS or Azure or Google Cloud. We have in-house expertise and decades of experience in all of these areas, including product management and interaction design. So please feel free, give us a call, and we'll be happy to support you again. Thank you for coming for this event today, and I hope to see you all again next time. Till I see you then, cheerio, bye for now.